All right, everyone, welcome back. Let's continue the foundation engineering class. We are on chapter number 4, special cases of ultimate bearing capacity of shallow foundation. And today we will talk about this topic, which is the point number 7 of this chapter. It is about closely spaced foundation. So the effect of ultimate bearing capacity, it means if you bring two shallow two footings very closely, what will be the effect on the bearing capacity? So there will be like effect on each footing will affect the other one. On the bearing capacity, how we can estimate the bearing capacity of each of them. That obviously will depend on the space between the two footing. Yeah. Okay. So let's go then. Closely spaced foundation effect on ultimate bearing capacity. So, as you know, in the previous chapter, what we did, it was only for an isolated foundation, isolated footing on uniform ground, uniform soil. Okay. And we show that in that case, this formula is okay, effective to estimate the ultimate bearing capacity. Okay. But when foundations are placed close together, okay, the same soil, similar soil, and the two footing are very close to each other, then the bearing capacity can be affected by what? By the interference between overlapping failure surfaces. Okay, as you know now by now, everything depends on the failure surface of the foundation. In case of two soil layer, when the failure surface cross the border, there is effect. When it doesn't cross, there is no effect, there is no influence. Similarly here also, if you have two foundation, two footing near each other, if the failure surface, the slip failure of this footing touch or they meet somewhere, there will be influence. Okay, so this reference Stuart 1962 studied this situation, this kind of situation on granular soil. Okay, so if we say granular soil, it means there is no cohesion. It's like sand or gravel, no cohesion. And he identifies some possible interaction scenarios. Some of them or all of them are illustrated here. Okay, we have 4 possible cases. Okay, and step by step, we are going to see how to estimate ultimate bearing capacity in each case. Okay, as you can see here, the failure surfaces, these failure surfaces, they're almost independent. There is no interference here. But you can see here the interference is there. Okay, so here there will be obviously effect. This footing will affect each other. And you have here also another situation, a different situation. Here it's very close, almost touching. Okay, so today we are going to see in each of these cases how the bearing capacity, the ultimate bearing capacity can be obtained. But remember, this is for only sand, for granular soil only. And these are similar footings, okay? You have B here and B here, same size of footing. So in case of collective soil, you can do it. You can take it as a research topic and go investigate what will happen. All right. So the angles alpha, alpha 1 here. We have alpha 1 here. Yeah. Here also alpha 1. This one is equal to phi prime, which is the friction angle of the soil. Okay. And alpha 2, this one, equal to this 45 minus half of phi prime. This is like just similar to the delta gauge theory. Okay. We have alpha 3. Alpha 3, you can find it here, for example, in this case. Yeah. Alpha 3 is equal to 180 minus twice phi prime. Okay. If you didn't understand this, it will not be a problem. You will be able still to estimate the ultimate bearing capacity. Okay, then let's start with the case number 1. Okay, the first case, this one. Okay, for this one, center to center spacing. Okay, that is also very important. Okay, the spacing, it is not between the borders of the footing, it is from center to center. Okay, so the case 1 is when the spacing, center to center spacing of the two foundation is larger than this x1. Okay, you can see x1 is corresponding to where when you have limit here. Okay, the failure surfaces are just touching, like here. They are not really touching, but almost touching. So if the spacing is equal to this or completely higher than this, then you can see that the failure surfaces, the rupture surfaces are not overlapping. Then you can say that the ultimate bearing capacity of each continuous foundation can be just given by the Chesapeake equation. Okay, but in case of granular soil, it's only for granular soil we are talking about here. So this equation, the same equation we know since chapter number 3, the general equation. Okay, so it means this ultimate bearing capacity is the capacity for each of the footing. Okay, each of them will have this ultimate bearing capacity. Yeah, and N, Q, and gamma, you know already. These are Tesla gauge bearing capacity factor. And remember, this is for strip footing, continuous footing, okay? Continuous foundation, strip foundation. So if you are dealing with square or circular or rectangular foundation, please remember to add the shape factors, okay? Yeah. So next, case number 2, we have this now, okay? Case number 2, you can see now that there is interference, okay? The two failure surfaces are overlapping, but how much the overlapping is occurring, okay? You have this situation where then the center to center spacing of the two foundation is satisfying this condition, okay? X2 less than X1.